I want to first ask a small question. How many of you are from academia? Raise your hands. How many are from small to medium companies? And how many are from large corporations? Ah, corporations win. Okay, today I'm going to talk about mutation testing and the opportunities and the pitfalls that we will face when transferring this knowledge into industry. So let's go. This is why we do what we do, because we don't want $250 million equipment like that on Mars surface. That happened because of an integer overflow that could have been detected quite easily, but well, that's the biggest costing bug in a generation, I think. I hope the guy sleeps really well at night. So, but what happens to software today is that software is now everywhere, and I really mean everywhere. Now you have people using software in toothbrushes, and the users are not happy about this because when they want to brush their teeth, they have to wait for a firmware update. And of course, what happens when you update your firmware in the bathroom? It fails. And then you can't brush your teeth. It's very difficult for such a function to happen. So what we need is a better test quality to make sure that these things don't happen. And what we say is that if we have better test quality, we will have fewer bugs. We will not get to no bugs, but we will have fewer bugs, which actually is a risk reduction strategy. So, where does mutation testing come from? Of course, by now you already know what mutation testing is and what promises it will give to industrial people. It's already been done successfully in SUB, and we received a really good testament from Joachim that it's going to work. So I have a very easy pitch to sell, but let's see how well I can do it. So if this is our test suite, it doesn't look like that, but it's a good test suite. And this is our software. What we do in mutation testing is that we inject our software with a bug. And what you get after injecting your software with a bug? You get a mutant, of course. And now the job of the test suite is to detect this mutant from the original software. So we need a change in behavior. So if the test suite fails or results in an error or something like that, we say that this mutant is killed, because we could tell the mutant from the original code. But if the test suite says everything is fine, then there's something wrong with that test suite. And then you have a survived mutant that you need to work on. The problem, of course, in industry is that when you go over all of these mutants, it will take a lot of time to do. So you need to actually reduce the costs of this process, and you need to bring it to be more accessible for people in industry. So today I'm going to talk about 3 scales, and this is the main pitch. So that's a small scale company, a startup, or just right after they started up. This is a medium scale company that they have multiple products. The products are fairly large, but it's not exactly a giant corporation like Softbook. But then that's the corporate level stuff that actually dominates the room. So I'm going to talk about all of it. First, if you're in a startup, in our experience, mutation testing works really well. If you have 10,000 lines of code, 20,000 lines of code, you can put mutation testing as a systematic way to analyze your system, write test suites, and then this can become part of your development method. Because your scale is not large enough so that you hit a wall on the costs. This can be part of your system. You can use it. Of course, there are challenges there, as Joachim already explained about it. But the challenge is not the cost anymore. You have no reason to say that this is really blocking for me. And in practice, we've experienced that the startups that we worked with that actually adopted this method have resulted in really, really high quality software. They refactored their software often because of the way that they needed to write tests. And in general, they got really good quality code after a while. And they were really happy with using mutation testing from the beginning in their software. But what if you're from a medium-scale company? Then you need to really think about where you want to use mutation testing. You can't use the general mutation testing, mutation operators, for example, to generate 100,000 mutants, because that just doesn't work out anymore. You can't. 1 minute? Okay. Okay, so I'm going to go really, really quick over this. So you can't do that, and you need to customize your mutants for that scale. So you need to actually search for your bug database, and you need to find patterns and generate few mutants that are important for you to catch, so that your method is now not top-down, it's actually bottom-up. You want to fix as many critical bugs as possible before shipping. If you're a big corporation, you can use mutation testing in your smaller teams, as the experiment in Sub was. We basically, if you have softwares that are small enough and smaller teams, you can actually use it as if it's a startup within a big corporation. And otherwise, you can use mutation testing in the sense that Benoit talked about, that you can actually go very coarse-grained and go very minimalistic, and then you have a company like Google even using the system that way and getting benefit out of it. So thank you very much. You see all of our representatives are happy in the end. And if you want to do mutation testing in University of Antwerpen, we are always open for further collaboration with you. Thank you very much.
Thank you, Ollie.